This video, I will do an example of continuous money flow, and in particular, we're going to be looking at future value. So let's start with the formula for future value of a continuous money flow, which is the integral from A to B of our revenue or income stream times e to the RT dt. Now, R of t is revenue or income. Revenue is the money that a business takes in. Income would be the money that an individual earns or takes in. Now, revenue or income can take one of three forms in these problems. So let me see, three forms. One of them would be a constant function. So let's say you earn $50,000 a year, and that's not going to change. Then your revenue function would be $50,000. That would be your continuous stream of annual income. But let's say you have a nice boss, and he says, I'm going to give you a $2,000 raise every single year. Well, then we have a linear function. You're going to start with $50,000, but then you're going to increase that by 2,000 times t. So when t is equal to 0, meaning right now, initial starting condition, you have 0 times 2,000 is 0, plus 50,000 is 50,000. After 1 year, t is 1 times 2,000 means you'd be making 52,000. And when t is 2 times 2,000 is 4,000, plus 50 would be 54,000, et cetera, et cetera. More realistically, employers like to give a percentage. Say, okay, I'm going to give you a 5% increase in your pay every year. Now, for the sake of these problems, we have to assume that this is going to be continuously compounded. So we're going to take the 50,000 and multiply that by E. And again, if it's a 5% raise, we would raise it to the 0.05t. So what this is, this would be a $50,000 starting salary with a 5% continuously compounded increase. And that's what we need to be doing in this particular problem. So read the problem, and there's two parts to it. First of all, we have to figure out what the revenue function is. So the revenue function here is $350 per biweekly paycheck. That means every other week for an entire year. So on an annual basis, that's going to be 350 times 26, because biweekly would be 26 times a year. Now, we also know that you plan to increase the amount of the investment by 5% a year. So we're going to take that $350 times 26 times a year, and we're going to increase it by 5% per year. And so we're going to multiply that by e to the 0.05t. So when we multiply 350 times 26, we get 9,100 e to the 0.05t. That's your revenue function. Your interest rate in this particular case is 4.45%. All right, so 4.45% is the annual interest rate. All right, so now we can put all of that together in our integral. And this is over 20 years. So our future value is going to be the integral from 0 to 20 years of 9,100 e to the 0.05t. Now that's your revenue function. I'll put that in brackets just for now. That's your revenue function times your e to the 0.0445t dt. So this is coming from your interest rate. And of course, this is your revenue function. Well, we can simplify that a little bit because we're multiplying these e's together. Same base, all we have to do is add the exponents, our exponent rule. So the integral of 9100 and 0.5% and 4.45% is going to be 9.45% or 0.0945t dt. And there is the integral that you want to integrate. So your future value will be 9100 divided by the 0.0945. And we get that as a result of doing U substitution on the power of e. E to the 0.0945t evaluated from 0 to 20. Plug that into Desmos. So your antiderivative then is the 9100 divided by 0.0945, whatever that is, e to the 0.0945t. And then you want to evaluate that from f of 20 minus f of 0. And what you will end up with will be something like $541,000, 124.39. That would be your future value. So once again, you're taking a sum of $350 every other week and putting it into an investment that has a growth rate or an interest rate of 4.45%, but you're increasing that $350 by 5% per year. All right. Hope this was helpful.